Hello, can you hear me? Yeah, hi. I'm Tijo. I'm manager solution architect at Imply. Imply is the creator of Apache Druid. Been with Imply almost 4.5 years now. Seen how this company is growing, how this tech industry is transforming. When I joined, I was the 60th employee. Now the team has grown a lot. One person in India, actually only 2% in the world as a solution architect when I joined. Now the team is over 20, almost 10x growth. I mean 20x growth. Yeah, before that, I just to give you some background. Maybe I'm coming from a engineering background. I was part of Huawei R&D in big data. I contributed a lot in Apache Spark, and Huawei also is one of the biggest contributor for Hadoop as well as Spark. Outside US, Huawei is the biggest contributor in the world, and that too in India, in the big data space. So any contributors or committers or even PMCs, you can see the line track somewhere in Huawei. So that's the entire journey started from there. Yeah, then I moved to, of course, the veterans of big data, which is Hortonworks. Later on merged with Cloudera. That's the time I thought, okay, it's the right time to move on. Okay, so that's about me, and I just wanted to know about you. How many data scientists in the team? Data scientists, data engineers. Great. Anyone working with Apache Druid? Anyone heard of Apache Druid? Yeah, okay, thank you. But we have more evangelization work to do. Anyone working on streaming side? Okay, great. That's good. There also, I see some opportunity. We need to evangelize more on the streaming part rather than the batch side. Okay, so what is streaming? Sorry, this is our overall agenda. I might be moving a bit fast. Stop me if you have any issue in following. Sometimes I will be skipping also. It's an assumption that you already know things, and I'm not repeating what you already know. So this is an introduction session. We'll talk about streaming, we talk about Kafka, and we talk about Druid. I'm not going deep dive into Kafka side because there is one of the PHP speakers who wanted to talk about that. Yeah. So what streaming? So basically, if you look at this, there are two worlds in the data space. One is the batch and one is the stream. Why those are different? Because that landscape is different, that data infrastructure is requirement is different. Most of the time, the batch workload happens at the end of the day or end of an hour or end of a week or end of a month. So during this period, there will be a burst of hardware requirement. Scaling is one of the key factor. The nodes will grow up in the infra during the end of the day from maybe a couple of servers to thousands of servers. And after that, come back normalcy to whatever is required for the operational purpose. And it's expensive and it's time consuming. Everything is written into the disk and retrieved from the disk. As you know, any operation which is persisting in nature is time consuming and it's expensive also. And the other requirement is high throughput because 1 month of data is being processed within a couple of hours. So the requirement is high throughput. When you look at the CPU utilization, the CPU utilization often surge more than 100 or almost hit the 100%. That assumes to be the good utilization of the software. Okay, so in batch world, 100% CPU utilization is perfect. Whereas in the stream world, it's not. Anyone from microservice background? Okay, great. In microservice, what could be the a good CPU utilization? Yeah, 60 is very good. Very good in the sense we cannot go beyond 60. 60 is upper watermark. So that means we are wasting on 40%, right? Yeah, that's it. Yeah, that's the world we are living. We have to give away something, and it maintains the order. That means that even though data comes late, there is a mechanism you can pull in the data and make it in an ordered fashion. Whereas in the case of streaming, it's fast. Is there any requirement to persist? No. It will be in memory. It will be in memory in one system and goes to another system, and that also will be in memory. Whether it need to be persisted, yeah, maybe not my actual requirement, not for the BAU, but what if one of the node goes down? So somewhere I need to persist, but from the business requirement wise, it's not a persistence, it's not the key requirement. Now, how about the data loss? Yes, if it is in memory, then definitely there can be memory data loss. Whether it recoverable, if it is yes, we are good, right? So that is the nature of a streaming job. And whether to do replay, maybe, may not be required. Basically, it depends. If the data is already processed, then no need to replay it, right? In case of any data loss, yeah, then the requirement of replaying is required. So what I mean to project here is the requirement from the streaming world and the batch world is entirely different. So that's the reason this often doesn't collaborate each other. When we talk about how many are from big data, any big data warehousing, okay. So often in this case, we call it as in the old way, we call it as the data once they land into the data warehouse, data will be put into multiple layers. We call it as landing layer, curated layer, published layer, and the data move from one layer to another layer on the end of the day or end of the month, or then the data will be available. Whereas in the modern world, we cannot wait for one data to be visible, to be usable to you at the end of the day. For example, assume you take an insurance policy. Do you want to wait for the end of the day to confirm that your policy is accepted properly or not? Or you want the immediate response? The answer is you want immediate response, right? You want to book your ticket. Do you want to wait till end of the day to see, or a couple of hours to see the ticket is booked successfully? No, you want to see it immediately, right? So that's the reason the requirement has changed. Expectation was changed. Back in the day, it was not the case. We are okay with that because we are not system savvy. Not much apps were there. Everything you have to go to a office and do that. They will say, yeah, done. This is your receipt. If it is not there, I mean, the policy is not issued, come back tomorrow. Okay, that's what the world was. Now the world has changed, more of automation, more of application. Okay, now what is stream processing? Oh, sorry, maybe, sorry about it. So in case of a stream processing, sorry, I want to be very mindful of the time, so that's the reason. In case of a stream processing, so I would like to showcase, we need some mechanism, as I told you, where to store the data, but at the same in a streaming fashion. As I mentioned earlier, batch system, it can persist, but it's slow. We need a system to store, persist the data whenever it comes through. Okay, and from there, I can handle all my other pipelines. So in case one of the node goes down, I have a persistent store, which is optimized for a streaming part, where I can retrieve the data. So that is Kafka, right? So in any streaming platform, where the data will first land into the Kafka, which means now I am safe. Even if any of the node goes down, I'm okay, I'm fine, right? I can retrieve the data from Kafka. That's a purpose of Kafka, right? So Kafka need to be there in any architecture. That's doubtless. So the data comes from different places, goes to Kafka. Then there are two sections. The data need to be queried. like a database, right? Stream, you cannot query the data as a stream. You cannot fire an SQL query to a stream, right? So data need to be queryable like we do in our older OLTP system, any other relational database system. That's what our inherent applications are developed based on the OLTP system, right? So there is a requirement for a DB. Okay, so that is this part. Okay, and another one is maybe the data is required to read by any pipeline, do some processing, maybe send an SMS notification, do something like that, that sort. That is the second part. Okay, so these are the two areas where we broadly categorize how the data can be retrieved from the Kafka. Okay, now where Druid sits, Druid is here, which means that whenever you ingest the data into Kafka and the data is available in Kafka, within 500 milliseconds, that is even configurable, there are trading platform, algo trading platforms will make use of Druid and retrieve the data or make the data queryable in a SQL way within 50 milliseconds. Okay, so that delay will be there in almost all the consumer side because that is something configurable. Okay, now that where the Kafka sits, I mean, Druid fits. Now we'll give a quick introduction of Kafka since just to set the stage. It's a modern distributed platform for data streaming, scalability, hundreds of MBs of throughputs, many TBs per second servers, and it can make use of a commodity hardware because even though one of the node goes down, it's fine. There are other nodes we can handle it. It's a distributed, it's a scalable as well as distributed. Distributed in the sense, even if one node goes down, other node has the capability to process the same message without any interruption. Now, strict ordering and it's persisted. Okay, so there are different levels of persistence. I'm not going into there. And at any point of time, you should have that capability to rewind and play. Okay, something is broken in the pipeline. Okay, you know, at this point of time, at this message, till this message I have write and processed. Now I need to go back and read it again. So that is rewind and playback. And distributed by design, replication, fault tolerance, persistent partitioning, and elastic scaling in nature, all these are supported. Okay, so that's about Kafka mainly, but ultimately what is Kafka? Basically, it's nothing but a write ahead log. Ahead of it, write ahead log is nothing but to write the events at the end of a queue or something like that. Okay, it's just that, it's as simple as that. Okay, but at the same time, the one producer, which is this part, can write into the Kafka, which is the write ahead log, and the consumer has the freedom to read at their pace. Okay, so that's a thing. Now, how do you write? You write it as into a topic. We call it as a topic, and you write the data into a topic, and there can be n number of topic you can define. Maybe for fraud analysis, you define a topic. All the fraud related data can go into that topic. Maybe in some other use case, some other topic, like that. Now, whenever you write something into one topic, this is one node. It replicates into other node on real time, and I mean, there is less likely that all the node go down. So what normally happens is we will persist only in one node, and other nodes we keep everything into memory. And yeah, persist ultimately not immediately. So you will get the better throughput and performance. Okay. Now, quick introduction about Druid. So what is Druid? So the history starts like this. It's primarily defined, I mean, created from our founders in Meta Market in 2012, that time period. Okay, the requirement is basically coming from a clickstream analytics data. Why that is important is it need to be very cheap. The reason is how much one click could make money. Point not one, maybe cents. And it's not worth to store the record because the money generated or revenue generated out of that click is more cheaper or less profitable than storing the data. The storage itself is expensive than the money it generates. So they were looking for a mechanism to provide a cheap analytics. And often, you know how this ad exchange works. When you create when you have a website and assume you are ready to publish something, ready to give it for Google for publishing their ads. Google actually hosts a marketplace or for a seller and buyer to connect each other. And at the time when your website loads up in somebody's browser, there is a bidding happens in real time. And who wins the bid, their ad is placed there. Okay, so if there is an analytics happening there, right? And that has to happen within milliseconds before the actual page loads up. So that is one of the reasons. So the Meta Market is one of the key competitor in that space, and they were the leading competitor, much highly revenue generating than Google, and then comes InMobi, and then third place is only Google. Yeah, and so it's created for high volume, high velocity, and high complexity. Open sourced both Druid and related ecosystem back in 2017, I believe, 17 or 15, I'm not sure. And from there, things have started really growing up. Netflix is the other public company who adopted Druid. Everything and everything coming out of Netflix devices or your browser, everything is stored in Druid. The second company is Twitter. Complete ads were captured and information, all ad related data is captured in Druid. I worked with the Twitter for some time. They're having around 30,000 clusters, 30,000 node where Druid is deployed. And it's open to the world. They don't charge for anything. If you want to do analytics in Twitter, you can just go ahead and open a screen and do analytics, and you can find it out what type of ad makes sense, what type of ad give me more revenue. And these are very expensive queries, right? And they give it open to world for free. Yeah. Yeah. Now, where Druid fits in your data ecosystem? So let's say the case of a CDC or it's data come to Kafka, then do some processing, maybe some Flink or Spark streaming, some processing. That once the data is processing enriched, then the data will be pushed into Druid as a data store, as a database. Yeah, from this database, you can do analytics. You can also do some sort of, you can create apps, stuff like that. Yeah, who all are using? For example, Confluent Cloud. You might have heard of Confluent Cloud is nothing but a Kafka as a service offered by Confluent. So Confluent Cloud has, it's using Druid for their entire monitoring of the cluster. 5 million event per second is the current rate at which they are generating the data, around 350 queries per second, and almost 24 TB of data per day. Okay, so this is the data which they are generating. Who is the next? Atlassian. Somebody was here from Atlassian. Yeah, we'll find out. 25 million users. They have 25 million users. Less than 100 millisecond latency. I worked with Atlassian team. It's not 100 milli, it's 50 millisecond. That is their SLA. But they told we cannot put 50. Whenever it goes more than 50, I will get a pager. So earlier they were having multiple system to handle the workload. After moving, they are getting 5x performance improvement. 1,000 days, another company, they have 180 metrics, that huge table, right? Huge table, and it's around 1.5 billion events per day. And after moving to Druid, it becomes 10x reduction in query latency. So any of our customer, when they come to us, what we guarantee is Druid offer less than 1 second latency. You fire any query, you will get less than 1 second latency. Okay, so which is not possible. Even if you have hardware in other big data ecosystem, that is not possible. Okay, and especially why it is so relevant? If you are an internally powered application, which internal employees, okay, it's okay. We can ask the employees to wait for another 5 or 10 seconds, not a problem. That cannot be done if you are exposing this to an outside world, and that is your core of your business. If that is the case, no, then we cannot wait. We cannot ask the customer to wait for 10 seconds, result will come through. Media Lab, again, 100 billion events per second. The reason I am bringing all this is to show the scale, the kind of landscape. It's not the same for each customer. Everyone is doing at scale. Some have less number of columns, some have huge number of columns, like that, right? Yeah, Netflix, 2 million events. Yeah, Spotify is using Druid, Amazon is using Druid. So back in the day, so I was involved in Spotify as well. They completely replaced ClickHouse with Druid. Earlier, they were having scalability issue with ClickHouse. ClickHouse also is a great tool, but as the volume of data increases, it's not so easy to scale. Yeah, Confluent. If you are using Confluent, you can see the analytics. It's a directly powered from Druid. Yeah, these are the other companies I just wanted to highlight. These are the companies which is using Druid at scale. Yeah, from India, Paytm. Yeah, they are also having around 160 terabyte of data every 30 days. Yeah, huge volume of data. Oh, okay. Sorry about. Yeah, I don't like this animation. I don't know. I normally removed it. Okay, so how does it work? So this is just to give a overview what is in the Druid platform or Druid asset database. So we have a broker where the data, the queries comes to broker, and broker actually knows how to split your query. Basically, Druid is nothing but a Lambda implementation, which you might have heard of, Lambda architecture. So it's a Lambda architecture implementation, which means that it's the broker receive the query, split the query into multiple small queries, and distribute to multiple services. We call it as indexer or historical. And then that data will be ingested into a segment, one big file. We approximately 5 million records will be combined together and create a segment. Okay, so create the segment and push it to deep storage. The reason we do that is deep storage is nothing but any blob storage. The reason for doing that is the requirement is to have low latency, less than 1 second. So if the data is in S3 or any blob storage, it's practically not possible to query the blob storage, which is effectively slow, and get the result in less than 1 second. So we always keep a copy locally in the disk, and the data is managed completely by the Druid itself, how to load it, how to balance it. If one node goes down, what happens? Another, this segment, this data unit need to push to another node and stuff like that. Okay, this will be handled by this. Okay, so and we have master nodes will do all the management activity, and basically the indexing. I mean, indexing is nothing but ingesting the data from the real-time or batch system. So that also is done by Druid. So you don't need a separate pipeline for ingest the data. They will all be handled by Druid itself. So querying as well as the ingestion is handled by the Druid. Good. I'm actually moving really fast. Sorry about it. Yeah. So what to do? How this ingestion works? Basically, it connect to the source system. If it is a Kafka, it connects to Kafka. If it is a data is in S3, which is a batch, it can connect to S3 and ingest retrieve the data, create the segments. And now the second question is it scalable? So it's a linearly scalable. I'm not exponentially scalable. It's a linearly scalable, which means assume you can ingest 10 records by, let's say 10 is not, 10 million record in with one set of hardware. You can ingest 20 million record with if you double the hardware. That means it's a linear in nature, right? So you just need to add more nodes. And ultimately what it'll create, it creates a segments. And segment is what? It's columnar. Advantage of columnar is assume if you are handling one column or querying one column, you don't need to do the complete, read the complete data set, right? It's only some portion of the data only need to be read. So that's a columnar, and it's a dictionary encoded, which means that normally we in relational database we do with the normal forms, 1NF, 2NF, 3NF, and BCNF. Maybe 3NF is and BCNF is the ideal normal forms. As mean once the data comes in, it will be converted into. I mean, you model the data in such way that the static data will goes to one table and all the transaction data goes to another table, and you join the data to retrieve them, right? For example, a foreign key will be defined, and all the in the foreign table, the columns will be having numbered as 1 to 3, right? Like that, right? So those kind of things that normal form conversion is inherently can handle by Druid. You don't need to do that. You just bring your data. Internally, it will manage that into, which we call it as a dictionary encoding. It's compressed. The beauty of this compression is compression take time, as you know, it's time consuming. But if you want to read the data, normally you need to decompress it, right? In Druid, you don't need to decompress it. At the compressed data itself, the data can operate. I mean, the query can operate. Now, advantage is, assume a 100 GB of data. When you compress it, it becomes, let's say, 10 GB. Now, the 10 GB, where the benefits is, you don't need to transfer the 10 GB data over the network. You your 100 GB of data to the network. You just need to handle only 10 GB of data. So that there is a network efficiency. More than network efficiency, disk efficiency. The slowest performing unit in any system is the disk. So when you compress it, you will get much more benefit, much more performance. Yeah, so that's there is a white paper on that. That's the entire basis where Druid was created. It's been published by our founders when they were studying in the college, and based on that, the Druid is built on top of that white paper. So there are various techniques. It's not one single answer I can give. Yeah, I'll share the link later. Okay, I'll discuss that. Okay. I'm sorry, I'm running a bit late. Yeah. And it's indexed. See, one of the biggest challenge in big data system is data is not indexed. If you want to query a data or a set of data, you have to read the complete file, right? Whereas in Druid, the data is indexed, which means if you are querying let's say select star from blah blah blah, where country equal to India. In that case, only the files with India, where the data value is India, need to be touched. Others should not be touched, right? So that is not possible in other big data space. Yes, there is something called partitioning. Yeah, that means physically you are splitting into a separate folder for India related data. But how many columns where you can do this partition? It's impossible to do that, right? So in Druid, all the data is by default indexed. You don't need to mention anything. Okay, so all by default it is indexed. Okay, yeah. So how does it work? So once the segment is created, segment will be moved to historical. It's where historical is a service. Okay? Name of the service. You can think about that's a power hose of reading the data. So move to the locally to the historical, and from there are other techniques like memory mapping and many other optimization, vectorization, and I'm not getting into all those things to read the data pretty fast. How fast we can read? 5 million record can be processed in 50 to 250 millisecond. 5 million record, 250 to 250 millisecond. That's the rate you can count on. There are better cases. I'm not getting into them in general scenarios. Okay, so and that too by one thread. That should be that is another highlight. Yep. Now this is a depiction of how the query happens. The query will be sent to broker, and broker split the query into multiple, multiple queries and fire it to their respective services and collect the response and merge it together. So the conversion logic of distributing it into multiple services is handled by Druid itself. Whether it's scalable? Yes. Same like as before, just a linearly scalable. And there is another cool feature here. It's called cold tier. So what we have seen in the data space, recent data are heavily queried that old data. Okay, so that means querying for recent data, you need more hardware. So we call it as in the landscape, we call it as tiering. There is a hot tier, there is a warm tier, there is a cold tier. Maybe cold tier is more than last 1 year of data. Maybe nobody even touched that, right? So that goes to the cold tier. Whereas in warm tier, yeah, very frequent. I mean, frequency is quite less. So the CPU to the data ratio, you need to maintain it in a different way in different tiers. And Druid inherently supports that. Okay, so that's about it. You don't need to do anything. The movement of data from hot to cold, hot to warm, warm to cold, all these things will be automatically handled by setting a rule. Okay, so that's handled. Okay. Any questions? I'm maybe another 5 minutes. How we are on time? Yeah. Okay. Yeah. So indexing, this indexing is called reverse indexing. What it will do, it will create a bitmap, and all this bitmap is compressed using roaring bitmap algorithm. So that also is in a compressed form. Okay. So when you query the data, it identify, yeah, for example, where a country equal to India. Okay, and this country is equal to India is distributed in 10 machines, and this is the page, means OS page cache where that particular data is residing. Each page cache is 4 KB in operating system. So that 4 KB block of data is identified, right? So it may not be that one exact data point, but it's that 4 KB because ultimately that 4 KB need to be, we cannot read anything less than 4 KB from the disk. Okay, so that 4 KB is mapped. So we call it as memory mapping. Okay, so that 4 KB is mapped already. Now that only that 4 KB will be brought into the memory and run. Yeah, okay. Yeah, sure. Yeah. Yes. So one difference in Elasticsearch is actually Elasticsearch index the keyword, right? Words, right? So that's one other thing we don't do at the word, but at the column level.
Yeah. So that whatever the architecture you showed, right? That query one. Yeah, that query one.
Yeah.
So it goes to the historical even means like the hot tier, cold tier also it queries, or only the hot tier it queries.
Okay. So when you query, uh, based on your where condition, okay, it knows, broker knows where to send the query. So if the data is not there in the, let's say on historical, it's only there in the real-time node, in the indexer, and it is not in the historical. It will fire only the real-time node, wherever the data is present.
So broker means like what intelligent it has.
So it hold all the metadata of the data in the Druid. So it knows how many segments, what is the beginning of this particular segment data, beginning data of this, end data of this. All this information is stored in the broker.
So it's a database or it's a messaging queue or what?
Oh, no, it's a Druid service. It's a Druid, within Druid itself, there are multiple components. So broker is one such component. I cut down many slides because I need to, so that's this confusion. Okay, so Druid consists of, I'll show you another image. Yeah, so this is the Druid architecture.
Yeah, I saw it, but
Yeah.
see,
So
there are, you showed right. The data goes to the back end, like for the storage nodes, and also locally the data is there. So how it will know that whether it is has to go to the back end for the query or I has to do in the local database?
yeah, so how it works is whenever something loads into the uh, uh, basically into the disk, from the disk to the memory or even to the deep storage or HDFS or S3 to the local machine. So these informations are passed through Zookeeper. Okay, and broker is keeping a watch of what is going on in the Zookeeper. Okay, and that means it knows whenever a segment loads, it knows that there is a segment which is getting loaded and it's publishing. So once it loads immediately, broker fire a query to that segment saying, asking for the statistics. So it continuously collect the statistics and keep it in memory.
Got it.
Yeah. Yeah, yeah, we are going there. So our vision is to, right now, there are some caveats, like it's not a good candidate for a heavy joins. Okay, so we support broadcast join, but we don't support, I mean, we support shuffle join also, but it's not a good candidate for shuffle join as of now. Okay. Yes. Yes. Okay. So maybe 6 months now, because the new engine to handle the shuffle join in a most competitive way is almost ready. We are in the beta phase now. So most likely by 6 months now, we are there. Yeah, and if anyone worked in the big data space, there is a so there is something called a yarn. Anyone heard of it? Yeah, yeah. So the advantage of yarn is the yarn knows where the data is and it create the container in that node so that the data will not be transferred across the network as much as possible. Okay. So the performance, then there is something called short circuit in HDFS. If the HDFS is a application layer on top of actual storage, but whenever it identifies the data is locally present, it do a short circuit. Short circuit means avoid all the layer and directly access. It's as good as directly accessing the disk. That increase the performance rate. Wait, now what happened when the cloud motion start? The data, it's need to be in the disk, right? In the HDFS. It doesn't have that capability, or it doesn't have a good performance when it need to be directly queried from S3. And it's not burstable. You cannot burst the HDFS from one node to, let's say, 100 node in few seconds. It cannot happen. Okay, so there is a different motion happening. And after that, everyone started thinking about separating the compute to compute and storage, right? Now that was happening for last 5 years. Everyone want to remove it and scale the way you want. It's easy to scale. Now the motion is everyone is coming back to the old world. Every architecture is designed in a way that it need the best part of the both world, right? So that is what is currently going on. I don't know whether I actually answered your question, but as per that notion, with the new query engine, it is highly performant when compared to the. Okay, okay, great. Yeah, we'll talk about it. Yeah. Yes, yes, thank you.
Thank you so much, Tijo. If there are any other questions, we can probably take it offline. But thank you so much, Tijo, for that wonderful talk.